Hey there, MyTech. I'd like to show you something I've been working on here to help make the calculations a little bit simpler. Keep in mind this is all rough right now and still a work in progress, but nonetheless, let me show you. So here on the left, you can see the typical MyTech battery and voltage drop calculation spreadsheet. We have our summary page, shows project name, number, panel number, and then the power source. Going on from there, we have this page that has a lot of information on it, and I'm not sure we really use a bunch of this typically, and kind of where the focus of simplifying comes in. And then the meat of the calculations here is where we actually input all of our information, such as the length of the runs from device to device, and then next to that we have our current draw, or our milliamps for each device. So let me go back here, and then here on the right hand side, in somewhat a similar fashion, but a little bit different. We'll walk through it here where we have project name, project number, date, uh, the panel part number, and then here we can input whatever we want it to be on the drawings, similar to here where we type SCPS or NAC number 1, whatever we need to here. Here's a summary of all of our stuff, or all of our circuits, and then the battery stuff comes down here a little further. Here is kind of putting everything on one page, both voltage drop and then battery amp hours required. So I've only got one calc page so far shown here, and here I think is where the biggest time saver will come in, but we'll take a step back and kind of walk through a quick calculation here. So I'll make up a project name as I've done over here on this side on MyTech calculator. Name it whatever, ABC Corporation, and then project 1, 2, 3, 4, 5, 6. Simple as that. And just to show you it, keep things a little separate, I'll name this NAC number 1. Okay, so here is kind of a confusing part on the MyTech calculator. To select a different power source, we have to select it from this table. This table has so many predefined power supplies that have been input over the years. Some may not really exist anymore, some may need to be updated, but in this table that never prints, so you never see this anything from, or anything except for this, basically. But here, if we wanted to change it to this MIR BPS 10A, we have to count down from this row 1, 2, 3, 4, 5. So we have to change this to a 5, and then as you can see here we change, and here we see the change. The links in this spreadsheet don't link to this power source cell, nor do they link to this text box up here. So those are two items where we have to change manually. We could fix it, but just haven't gotten too much into messing with this, just because it's the MyTech sheet, and yeah, I didn't want to mess with it too much. So we'll change this back to the FCPS 24S8, so our typical notifier power supply, which is very close and not the same thing to the Firelight FCPS 24FS8, which we'll get into a little later. So, some of the challenges on the cover page to make sure we catch and synchronize when we do these. So the other challenging part, well, inconvenient part, I'll say, is when we come here to change from speaker devices to just horn onlys. We have to refer to this cell on the power supply tab and read this little box. I mean, not difficult, just 5 minutes equals 0.084 hours, 10 minutes is, yeah, etc., etc. So we typically only do the 0.25 or the 0.084, and then that translates back over to, or translates right here to our battery requirements. So that's that page, and now we'll get into the voltage drop itself. So on our voltage drop, I just added some numbers, and then we'll go through and I'll show you some differences here compared to what I'm doing on this spreadsheet to hopefully help simplify things. But we'll see here. Okay, so we'll get to this battery requirements a little bit later. I want to walk through the voltage drop first. So, in order to help limit the number of things we need to keep open as we're doing battery calcs, currently we have to have, let me minimize this. So currently we have to have our drawing open with, say, a circuit we're doing calcs on, and we have to do this to both get our measurements, which we get our lengths here, or a measurement command. However, I typically look at the properties and find that it's 18 feet, and I'll add 10 feet just to account for 5 feet on either end of the circuit to drop down to the notification appliance, and I would typically put this as 28 feet in my calcs. So that's the first thing we have to have open is our drawing. The second thing is obviously the calc, and then the third thing will typically be our device data sheet. So we need to know that a strobe, and this is for the system sensor family of notification devices. I believe this is the P2RL and the SRL. So these are the newest devices that they have. So here we see that a strobe, and we typically do 24 volts, so that falls into this column. So we do the DC, and then the candela rating, the current draw, the candela rating, the current draw. So we have to have this open or commit these to memory. When you do them enough, you begin to memorize them, both for strobes and then the horn strobes. So we got to reference 3 sheets, or memorize this sheet, or print this sheet out and have it with us when we're doing voltage drop. And then we got to go make our measurement, mark it in a length box here, and then our strobe current draw here. These numbers don't match this drawing. It's just for having it and kind of showing the triangle of references here that we have to make. So once we get that, we enter in all of our stuff, we get our voltage drop, and then hence our power supply page will give us our battery needs shown here, and then we'll copy this page, put it on the drawing, which is typically right here, this battery calc section of the drawings. And then if we only have 1 or 2 circuits, if it doesn't get too out of hand, we'll typically copy this voltage drop and then put it on here as well so we can see all of our devices and then where the numbers are coming from in this table. And I believe that shows up somewhere in here as far as all of the current draws for the NACs. Yeah, so they just combine it all into one here. So my goal when I was thinking of doing this spreadsheet right here was to minimize as many references we need to have open and make it to where it's a little simpler. So if I zoom out here, you can see this page or this section over here does not print. It's just for us to enter in our information. Before we get to that, let me make sure we have project name, project number. We'll change this. This is another neat thing. Instead of our table here that has all the links that reference to one space here and then not so much here and then definitely not in that text box, I've created a drop-down list to where we select whatever power supply we're using. So we'll go with the Firelight 8 amp power supply. And as you notice, when we change these from 6 amp, it changes here. It tells us they're 80%, and then these numbers change based on what the current spreadsheet that is available that I could find for the Firelight battery calcs. So they tell us that just the standby panel load is this, and the standby battery alarm load is this. And I'll show you that in a minute. Another thing here is a drop-down list for wires. So we got a whole bunch of wires that may seem like a lot, but this drop-down list actually references the NFPA 70 table, and this is the 2017. So this references the table 8, the conductors, and these are the values for our ohms per 1,000 feet that this calculation uses. So that's where this comes from, our wire resistance, and a double check that I'll show you in just a minute. So that's the brunt of this, and we'll come, like I said, come back to this battery section in a moment. So on this page, you'll see that our heading, this automatically references NAC1. So whatever we name this cell is, if we named it something more crazy like that, we see that that reference is updated here, it updates here, and then that prevents any kind of misnumbering on one area and not the other. So for now we'll keep it as NAC1, and then there's a little parentheses after the voltage drop calculation for circuit, and then here we'll number our circuit just the power supply and the circuit number. So once we have that, this tells us power supply, that this is a voltage drop calc for the circuit 1-1. So I'm trying to minimize as many places as we have to enter things as possible. So now what I want to show you, let me minimize this for now and show you what I have going on here. So as of right now, all of our editing and number entering will be in this table here. So I'll enter in just some values just to do 8 devices. So we show 8 devices, and whatever number we have here is mirrored here and then automatically device addressed in this column. To keep things kind of simple when you're doing it, I've added a column here that is easily translatable across the row here, so we can follow this as it gets more and more complicated, however many devices we have. One thing you'll notice is I enter a 100 here, and we have a 145 here. So, like I was telling you before, when I do just a rough wire length, since this is, I'll show you here in CAD, since this is a two-dimensional line, and we know everything's not flat, I typically take this number here, length, and add 10 feet, which that would be 28 feet. But here I even took that adding part out of the equation and just put exactly the two-dimensional distance you find in AutoCAD. So if we were to say our first device is 100 feet from the power supply, we enter 100 feet. Up here is where this changes the total distance. So we can change the ceiling height to whatever it is in the field. So it's here if I put 5 feet. So this is thinking 5 feet from the ceiling down to the device. 10 feet, I'd just leave that as 10 feet just to be safe. So this takes 10 feet down to the first device, run it, do 100 feet, and then 10 feet down again to the second device. So that's where we wind up with 120 feet. So I can show you here. So we got 120 feet for our 100 feet, and then our two drops. And now we add a 25% safety factor. So, no, that's not right, because I did, instead of taking the drops into account, I take just the 100 feet. So I take the 100 feet, add a 25% safety factor, and then I add the 20 feet, the 10 feet for one and 10 feet for the other. So that's where I come up with 145 feet, and then etc. down the circuit. So the 25% is only for this measurement. It does not take into account the ceiling height. Safety factors can be whatever we want them to be, but I think that kind of fits what we're doing in the drawings best. But we can change these numbers to whatever we want, 100%, 50 feet, whatever they want to be. And then in the event we need a Class A circuit, this number 1 means it's not a Class A circuit, and 2 will make it a Class A circuit, which should double all of our circuits here. So that's what it does. It just doubles all of the circuits if we're doing a Class A. So we take into account all of our necessary wiring. So from there, I like to show you my idea of now having only 2 references open while we're doing voltage drop calculations. So I've created some drop-down lists here that have some notification devices, not all of them, but the system sensor and the wheelock ones. So I'll show we can select the P2RL and the SRL strobes. And now to eliminate needing this page for all of our memorizing of the current draw of every device that's out there, here we don't enter the current draw, we simply enter the candela that we see in CAD. So like if I was going to do these 4 notification devices, I would show here, ignoring distances for now, I would just put, okay, this first device is a horn, so I'm going to put 75. The second device is a horn, so we stay in this column, put another 75, and then these last two devices are strobes, and they're 75 candela, so we just put a 75 and a 75. So now we only need two references open when doing calc, so we put all of our horn strobe ratings in this column, our strobe only ratings in this column, and then you see they translate over, they automatically reference another table in this spreadsheet here that has all of our horn strobes and the candela ratings that are associated with each device. So that automatically looks up and pulls in the current draw for each notification device and populates in this table. So we almost eliminate the need for this whole equipment data sheet until we need to put it in the submittals. So to just do a rough current draw calculation here, I'll start out, I'll just do a 15 candela, and I'll step through all of the candela ranges and show you as I go through a 75 candela device, a 75 candela device. So this will be 110 candela horn strobe and 110 candela strobe. And again, these are referencing our horn strobe, and we can double check that. So we got 15 candela horn pulling 54 milliamps. And then here we show 15 candela UL max current draw horn, drawing 54 milliamps. So the first four current draws for horn strobes are 54, 74, 121, 142. You see that shown here is our first one is 54, second one 74, 121, and 162. So follows along here. That one, I misspoke there, that's for 95 candela. We can enter that in. I'll show you here. We can enter this as 95 candela as a 142, but don't always use that one. These 15, 30, 75, 110 are the most commonly used, but we can use whatever the manufacturer allows us to, and I've entered in those values accordingly here. So entering in just candela and just wire length without having to think adding wire length or creating any kind of additional safety factors there. I think the spreadsheet does that for us and covers our bases. So that brings me to, let's do the batteries. So if I pull this to the side here and show you that I have here the battery calculation sheet from the Firelight SCPS 24, the S6 and 8 spreadsheet that they use to create these calculations. So the way we typically do it here is this always stays a 1 just for the main draw. These we don't usually fill in unless we're doing something that needs auxiliary current draw or supervision. The only cells that we typically manipulate here are our NAC output 1 through 4. So I usually do 1 as far as number of devices and just add all of the milliamp draw so that we show 1 full circuit of 0.772 amps. We show that here, and as we walk through this spreadsheet, we go down, here are our battery calcs. So similarly, our battery calcs here mimic the standby load, the number of hours, which we can change that manually here to whatever we need them to be. Typically we keep that at 24 hours. Supervisory, that then summarizes our supervisory, which we see that match. Battery alarm load, .917. 0.8 amps. Okay, so so we don't show this number, which maybe we need to address that. But we do have our required time in alarm. So like they did it here, they just enter the number of minutes instead of having to translate that. So here I have minutes, we can make it 5 or 15. That adjusts similarly to the manufacturer's data sheet. We'll keep it at 5 minutes for now. We'll show our total standby current draws, about 1.64 amps. And then here I'd much rather use 20% instead of a derating factor of 1.2, which is 20%, but it doesn't explicitly say 20%. So then we have a total calculation of 2.46 amp hours. Here they do 2, but I've noticed that they do that because they hide away the decimal points. They round it down for whatever reason. So those match up with the manufacturer's data sheet. The only thing I think we might have to address is to put an alarm load. Even though it's just for 5 minutes, it's calculated here and here. I guess, yeah, we just don't have a place for it. So maybe we can squeeze it in somewhere there. Again, this is rough as it stands now, but a lot of good simplifying processes going on here. So, going back to the MyTech spreadsheet and this one, I'd like to compare for just everybody's sanity. So here we have the MyTech spreadsheet, and we follow along with the current draws shown here. We, like I said, either memorize these or we have a sheet to reference them for, but that always leads to the potential to mistype and put in an incorrect current draw. Where here, one thing I've done too is if you enter in 17 or so, it doesn't calculate and it comes up not applicable, so it doesn't work. It doesn't let you enter in a candela that doesn't exist. So it's kind of a self-check. One thing you'll notice here is I found we got all of our lengths matching up. So our feed is 637, our milliamp draw is 772. Here we have it in amps, but it's the same thing, 0.772 amps. But one thing you'll notice is that our voltage drop is not the same. So questioning where we went wrong, the one thing I found is here on the MyTech spreadsheet, we have this column that does our formula for voltage drop calc. And this may be just for a safety factor, but this column, or this summation formula, takes into account all of the current draw for every step down the circuit that we calculate. So this step-by-step calculation actually calculates everything in this column, where it should only calculate from the row that it's on and down. So if we were going to correct that, we would correct that from here. So if I remove this formula, just for illustration purposes, and then I show that we calculate everything down. So now we're just doing whatever step we're on, and then we're calculating down. So now we see that that is under our 10% voltage drop, and then we're only at 18.339. And this is at 18.368, but that is simply just because of the wire resistance. I have 3.19 from the table on NFPA 70, and I believe at the 14, so the value MyTech uses right now is the uncoded stranded 14 gauge wire, which is a 3.14 ohms per 1,000 feet. So that is the only difference we see at this number. This 3.19 is very, very slightly more of a safety factor. So if we change this to 3.19, alright, did that change anything? No, because I don't think this references that, so we have to change that here. 3.19. So now we see 18.386, 18.386. So just one safety factor that's built into the MyTech calculator that may not be necessary. That's up to the designer's call, but I'll show you another resource I've used other than the current draw formulas. So this is System Sensors, or Honeywell's online voltage drop calculator. So I've modeled a lot of this after the formula they have, which isn't explicitly shown, but it's backwards engineerable. So in this column we see our 14 gauge wire, and then at the very last device, and these are all the same P2RL, SRL candelas are 15, 30, 30, so we step it up this the very same way we did here. So at the very last device, we see we got 18.368 volts at the last device, which is 18.368 volts. That matches this spreadsheet that I've been messing with for quite a little while here. So this kind of confirms what I've got going on in this custom spreadsheet. And if this is adjusted to only account for current draws past a device that is on a circuit. So that may save us on doing a couple more devices on a circuit, or if we like the safety factors we're going with, that's all up to the designer's choice. So I think that's all I wanted to show you guys for now. I've got a note here that I'll make to show total. So these are a few things that I've noted for myself to do as far as more things to add to the spreadsheet. And if there are other things that you want to see or add in there, maybe make life a little easier, definitely let me know. But as of now, this is where it is at the moment. I'm going to put a thing here that says actual batteries used are 7 amp hour batteries, whatever we need. A header here, whatever else we need or think that make this a little simpler. Oh, and when putting this on the drawing, we could make the footprint a lot smaller by making it just this one group of cells here and throw it on the drawing, and we'll have every circuit listed out, not broken out device by device, but it'll give us a general number of circuits on the power supply, the current draw, the number of devices on each circuit. So it's a great summary of everything that's in the calculations. And then in the submittal data sheets, we'll see further the number of, or the actual circuit broken out, the distances between the circuits, and the step-by-step calculator. And that will be a little bit easier even on the drawings. I've used the step-by-step calculator that is similar to the MyTech spreadsheet. There are other calculators out there that do have a little bit different numbers when they calculate them, but they do a lump sum calculation, which they just take the length of the circuit and then the current draw, and then they run the calculation for doing voltage drop across one lump sum over one distance. So this is like the MyTech calculator, very accurate, a little more flexible as where we want to assign safety factors, and hopefully a little easier to work with, and then easier to put on the drawing to show that we have met our voltage drop calculation needs. The one thing I'll say is I've not seen, and then it's even illustrated on this calculator that the Honeywell offers. They don't do the voltage drop percent so much anymore. They just look at the end voltage. So if it drops below 16 volts, which is the requirements on most of the devices that I've seen nowadays, 16 to 33 volts. So we can run our circuit all the way down to 16.0001 volts, and we're still good on our voltage drop calculations. And that's illustrated here as well. We can remove this column if that's something you guys desire. That'll allow us to obviously put a handful more devices on our circuit, but this 10% voltage drop percentage factor then kind of goes away, and that just may be a spec requirement or a particular AHJ requirement. I'm not sure where that is necessarily enforced anymore, but just an idea. If you guys wanted more devices on a circuit, that's something we can do. But otherwise, This is the spreadsheet in motion as it currently stands. There are some more things that I've been trying to work on and kind of put in a spreadsheet just so we can calculate all sorts of things, like here a candela calculator. I found where they actually give us the room dimensions for candela it needs. So I'd like to expand this to ceiling mount devices, so if we ever need more than 30 feet, we can actually get a candelas per foot measurement, or a calculation anyway. But that is all just stuff that is in my head at the moment. Let me know if there's anything else you'd like to see added, change, or anything at all that you like or don't like, or whatever. Alright, I look forward to talking to you, and thank you guys for listening.